Hello, let's continue our Sudoku adventure with A Tidy Sum by James Kopp. So we have normal 6 by 6 Sudoku rules. That means in each row, each column, and each 2 by 3 box, we are placing the digits the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So the way these work is every time the line crosses through one of these bold region borders, or some these are called boxes, but they're more generically called regions. But anyway, whenever we cross one of these bold region borders, we create a new segment of the line. So this line gets segmented by these bold borders. So for example, we could call this the green segment, the purple segment, and the orange segment. Every segment on the same line has the same sum. So segments on different lines can have a different sum than on this line. But within this line, it's the same sum in each segment. So let's say this was 5. That would define, because it's a one cell segment, that would define our sum. So we could do, say, 2, 3 here and 1, 4 there, just as an example. So that adds to 5, that adds to 5, and that is 5. So it adds to 5. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, how shall we get started? Well, the first thing is actually this one. First of all, it adds to at most 6 because it has a single cell sum on it. And so how small could it be? Well, we showed that 5 works. It can't actually be 4. The problem with 4 is that there's only one way to add to 4 without repeating a digit, and that's 1, 3. So we could put a 1, 3 somewhere in this segment, but now this segment definitely can't have 1, 3. We need 2 different ways to add to it. So this is 5 or 6, and this is going to be either, if it's 5, it's going to be 2, 3 here with a 1, 4 here, because we have that given 4 taking out of here. If it's 6, then the two options are 1, 5 and 2, 4. So this wouldn't be 2, 4. So this would be 1, 5, and this would be 2, 4. So there's always a 4 over here in one of these two. Now, what does that leave behind? If this was a 5, the only two digits we can't use are the 5 and 6. And that doesn't work immediately. So let's just talk about that. No, 5, 6 works. It's just this can't be a 6. You can't put a 6 on this segment because this is a single cell segment. So it maxes at 6. We can't do 6 plus 0. So this would not be 6. So this would be 5 and 6 this way. If this was a 6, the two digits missing are 3 and 6. And again, this can't be the 6. So that would be the 3. So this is always the 6 for the row. We could actually just see that just for the row. None of these can be a 6 because they're all part of a 2-cell segment adding to a 1-cell segment. So that's where the 6 goes. And this is 3 or 5 depending on whether this is 5 or 6. Now, that does mean that this could be as small as a 1, but if it was a 1, actually, 1 prevents this from being 1, 4. So we would not add to 5 if this was a 1. If this was a 1, this would have to add to 6, and we'd end up with 1, 5, 6. So really, we can't add to 4. If we tried to add to 4, it would be 3, 1 here, and that would break. I can just show you what I'm seeing in my head. If that was 3, 1 there, this would have to be 2 plus 4 adding to 6. But that would mean that we don't have the ability to... Oh, sorry, no, does that work? I think I've mixed that up in my head, actually. Whoops. That does work. 4 does work. But I guess that's even better because it means this can't be 5. Because if it was 5, we'd have to do 1 plus 5. But a 5 here means that this sums to 5 as well. But we can't add to 5 here. It can't be 1 plus 4. And if it was 2, yeah, the 4 is over here. So that actually doesn't work. It's not a 5. It has to be a 3 then. Because the only way we're doing 5 is with a 1 here and a 6 here. But that just breaks this sum. So it's a 3. And that makes this a 6 sum. Because 6 is missing 3 and 6. And so we actually know what these are now. This is 2, 4. And then this is 1, 5. All right. That makes this 2, 3. And that makes up here 1, 5, 6. This can't be the 6 or the 5. It has to be 2 adding to 5. Whoopsie. I messed that up, actually. It's 1, 5, 6. This still can't be 5 or 6. What am I doing today? That's 1 plus 3. That's 4. All right. I'm getting there. Let's try not to make more mistakes. All right. So that was quite nice. Got the 1 plus 3 is 4. These two add to this one, which can't be 6. So this can't have 5 or 6 on it, I suppose. These two 6s look down. This can't be a 6 for reasons we've discussed. That places the 6 here. This does need 2 ways to add to it. So this has the same deal going on where this is 5 or 6. And so the outies are either going to be 3, 6, or 5, 6. So there's always a 6 in the outies, which has to go here. And so then this is 3 or 5, but we just said it can't be 5 because it can't add to 6. So it has to be 3 also, putting the 6 there. Same deal. That's 5 and 6. That's 2 and 3. So we're not doing 4 plus 3. That's 7. So we're going to do 1 plus 3, which is 4. This is a 5. 1, 2, 3 here. It's not a 3. This could add to as much as 5, so that doesn't really help us. What do we got here? So we're adding to 6. So we're either 1, 5 or 2, 4. Is there any restriction on that? I'm not sure. What's this? 2, 5? I'm guessing this isn't a 2, 4 because of uniqueness, but we're not going to use that. Uniqueness is just a general term for a technique where you add the assumption to the puzzle that there's only one unique solution. And when you do that, you can unlock ideas like you can't do 2, 4 here and 2, 4 here because there's nothing to distinguish them. But it's called a unique rectangle. But first of all, I'm not going to use that. Second of all, it's a little dangerous to use uniqueness in a variant puzzle because you have to really make sure you've accounted for anything like what that a line might do to distinguish it. I do think that it's not going to end up 2, 4. But anyway, what do we need down here? We need 2, 4, and 5. Right, so the issue is that there's no 1 on here, so this can't be 1, 5. So it is 2, 4, and this 4 looking down gives us the 2 and the 4 there. That's 5. Giving us 1 and 5, 2 here. That's our 5, so this can't be 2 plus 3. It's 2 plus 1 is 3. That's a 3, so these add to 3, making them 1, 2. All right, that's a 2. This was the 1, 5. And the 5 distinguishes it. That's 1, that's 5. That's 2, that's 1. That's 4, that's 2. Here we need the 3 and the 4, and we're done. All right. Cool puzzle, James. I enjoyed that. We kind of had a mirror symmetry here where I did a bunch of logic here, and that allowed me to kind of streamline the logic on this one. But yeah, that was interesting how these were forced to be 6 by the same sort of pattern here and here, where first of all, it places the 6 on the other one, but also it forces these to be 3s because 5 wouldn't have worked because these couldn't have been 6. That's really interesting. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.